In spite of their minute size, the total weight of this host of bacteria in the top foot of a single acre of fertile soil may be as much as 1,000 pounds. Ray fungi, growing in long thread-like filaments, are somewhat less numerous than the bacteria. Yet because they are larger, their total weight in a given amount of soil may be about the same. With small green cells called algae, these make up the microscopic plant life of the soil. Bacteria, fungi, and algae are the principal agents of decay, reducing plant and animal residues to their component minerals. The vast cyclic movements of chemical elements such as carbon and nitrogen through soil and air and living tissue could not proceed without these microplants. Without the nitrogen-fixing bacteria, for example, plants would starve for want of nitrogen, though surrounded by a sea of nitrogen-containing air. Other organisms form carbon dioxide, which, as carbonic acid, aids in dissolving rock. Still other soil microbes perform various oxidations and reductions, by which minerals such as iron, manganese, and sulfur are transformed and made available to plants. Also present in prodigious numbers are microscopic mites and primitive wingless insects called springtails. Despite their small size, they play an important part in breaking down the residues of plants, aiding in the slow conversion of the litter of the forest floor to soil. The specialization of some of these minute creatures for their task is almost incredible. Several species of mites, for example, can begin life only within the fallen needles of a spruce tree. Sheltered here, they digest out the inner tissues of the needle. When the mites have completed their development, only the outer layer of cells remains. The truly staggering task of dealing with the tremendous amount of plant material in the annual leaf fall belongs to some of the small insects of the soil and the forest floor. They macerate and digest the leaves and aid in mixing the decomposed matter with the surface soil. Besides all this horde of minute but ceaselessly toiling creatures, there are, of course, many larger forms, for soil life runs the gamut from bacteria to mammals. Some are permanent residents of the dark subsurface layers. Some hibernate or spend definite parts of their life cycles in underground chambers. Some freely come and go between their burrows and the upper world. In general, the effect of all this habitation of the soil is to aerate it and improve both its drainage and the penetration of water throughout the layers of plant growth. Of all the larger inhabitants of the soil, probably none is more important than the earthworm. Over 3/4 of a century ago, Charles Darwin published a book titled The Formation of Vegetable Mold Through the Action of Worms, with observations on their habits. In it, he gave the world its first understanding of the fundamental role of earthworms as geologic agents for the transport of soil. A picture of surface rocks being gradually covered by fine soil brought up from below by the worms, in annual amounts running to many tons to the acre in most favorable areas. At the same time, quantities of organic matter contained in leaves and grass, as much as 20 pounds to the square yard in 6 months, are drawn down into the burrows and incorporated in soil. Darwin's calculation showed that the toil of earthworms might add a layer of soil 1 inch to 1.5 inches thick in a 10-year period. And this is by no means all they do. Their burrows aerate the soil, keep it well drained, and aid the penetration of plant roots. The presence of earthworms increases the nitrifying powers of the soil bacteria and decreases putrefaction of the soil. Organic matter is broken down as it passes through the digestive tracts of the worms, and the soil is enriched by their excretory products. This soil community, then, consists of a web of interwoven lives, each in some way related to the others, the living creatures depending on the soil.